let's have a look at this scenario here. You are going to fire a cannonball at velocity 100 meters per second at an angle of 41 degrees. You're on top of a hill which is 50 meters high. Your ultimate aim is to find out this distance here, the range. Okay, so you've got to somehow find the range. Now, in order for us to find out the range, well, we've got to find out the maximum height first. Once you've got the maximum height, add it to this height here, and then jump to the free fall scenario where you're going to drop a cannonball and see how long it takes to hit the ground. That will give us a time from here to here. Okay, and then you remember you've got to add it to this time here. So once you've got the total flight time, then you can imagine your dad sitting in a car and driving at a horizontal velocity here, and then so once you've got the flight time here, you can imagine your dad sitting in a car and driving horizontally across. Okay, so first step is to find out maximum height, and then add it to this height here, and then visualize the free fall just in order to find out the time. Okay, so first step, maximum height. So yeah, we've got to break this up now. Break this diagonal thing up because it's at the moment it's quite complicated when it's diagonally. So break it up into the horizontal and the vertical components. Okay, and then jump to the velocity time graph. Hang on, and then jump to the velocity time graph. So this is when it reaches maximum height. So the time it takes to get to maximum height would be, well, use this formula here. So it would be 0 equals 100 sine 41 minus gt. So work out t, the time that it takes to get to maximum height. So it will be gt 100 sine 41, and then divide both sides by g. So it will be this 100 sine 41 over g. Because we're on Earth, we're going to take g as 10. Okay, gravity on Earth is 10. So really, we are dividing by 10. So we can just move this out here, and basically it becomes this: t equals 100 divided by 10 would be 10 sine 41. So the time that it takes to get to the maximum height would be 10 sine 41. Okay. Remember, this is just a time. We've just worked out the time it takes to get to maximum height. But to find out the maximum height, we've got to find out the distance traveled, which is this bit here. Okay, the area. So basically, get the 100 sine 41 here. Okay, and then times it by this distance here, and then divide it by 2. So hang on. So remember, this is 100 sine 41. Right there. 100 sine 41. So that's this bit here. We've got to times it by this time here, which is this bit here. Okay. So times 10 sine 41, and then we've got to divide it by 2 because it's a triangle. Remember. So we are getting this times this, and then divided by 2. Okay, that will give us maximum height. Max height. Okay, so let's tidy this up. So basically, we've got this times this, which is 1000, and then sine, well, this times this, which is sine squared 41 over 2. Well, let's just move this out here slightly. So it's basically this divided by this, which is 500. So 500 sine squared 41. So this is our maximum height. Okay. So our maximum height is that. So remember, we've got this maximum height now. We've got to add it to this. Add it to that, and then we can find out the time by the free fall by using this gt squared over 2. Okay. So anyway, we've got this maximum height. Let's add it to 50. Okay. So we are going to get that. Hang on. Let me just work this thing out here first. Hang on. Calculator. Hang on. Bear with me. Okay, so we sine 41, and then we've got to square it, yeah, and then times 500 equals that. Let's just say it's 215. Okay, 215 meters. So this distance here is 215. Now we've got to add it to this, which would give us a total height of well, hang on, a total height of 265. Okay, hang on. So really, we've got this 265 here. How long will it take for the cannonball to hit the ground? So jump to this h equals gt squared over 2. RH in this case would be this 265. G is 10, isn't it? So we can just visualize it as this, because t is 10 divided by 2 is 5t squared. Okay. So now divide both sides by 5. So 265 divided by 5. So that would be 5, remainder 1, 3 here, 53. Okay, 53 t squared. So t equals root 53. Okay, so hang on. So the time it takes from here to here is root 53. But then we've got to add it to this time here. Okay, this time here would be given by this bit here, which is 10 sine 41. Okay, so hang on, it's getting messy, but bear with me. So we've got to get root 53, add it to this. Remember, root 53 is from here to here, the time, and then we've got to add from here to here, which is given by this thing here. Okay, so 10 sine 41, 10 sine 41. So this is total flight time. Let's just call it flight. Okay, so let's work this out on the calculator. Clear everything. Hang on. So remember, it's 10 sine 41. So 41 sine here, and then times 10. And then times 10 equals that. Hang on, let me just do that again. I'm not sure there. 41 sine, and then times 10 equals this, and then we've got to put it into memory. Where's memory? Memory store. Okay, hang on. Okay, so we've got to root 53, square root it. Where is it? 53 square root. Where is it? Here. And then we've got to add it to our memory. Equals that. So 13.8. So 13.8. So flight time is 13.8 seconds. So basically, just work this out on the calculator, work this out on the calculator, and add the two. So our total flight time is 13.8 seconds. So back to here. So flight time is 13.8 seconds. Now imagine your dad sitting in a car now, driving at this velocity. Okay, so now if it's 1 second, he would have travelled this far. 2, it would be this. 3, well, basically, get the total flight time, times it by this. So range equals 100 cos 41 times 13.8, was it? Yeah, and then basically now just get this times this, whatever that is, and then it would be cos 41. Okay, well, let me do it. Sorry. So here it would be this times 100 would be 1380. Okay, because 13 here we're moving it there, and then cos 41. So our range is this: 1380 cos 41. Okay.